Day, Americans, stand by for news.
Jack Harvey.
I'm Jack Rickard with EVTV. This is my compadre and consigliere. Hello, Brain Noto.
Hey, good to be here.
It's Friday, Brain.
It is Friday, and the weather has really changed out here. It was
Yes,
hotter than heck earlier.
It was a record 81 earlier in the week, and it's cold and rainy now.
Cold and rainy.
What are we bringing?
Well, we've got a couple of bottles of wine today. Our friends from the FedEx showed up with some whites, some Burgundies, both from the Montrachet area of Burgundy by Beaune. And we have that we already poured a Pouilly Montrachet and a Chasson Montrachet.
Ye gods, man, this should be some of the best Chardonnay wine in the world.
It is, in fact, some of the best Chardonnay in the world.
Fortunately, I've got one of the best Somalians, but what the hell is this stuff?
Well, what
happened to the cork?
This is well.
Did they teach you that in Somalian school?
Well, this is a special cork. It's a fused cork, and it's like a fuse when
it explodes.
Yeah, it explodes.
Wine trade drink.
Yep, and you just have to dig out all of the pieces. But this is the part. You make sure you get the bottom part out without letting the cork chunks go into the bottle. If you can do that, you're a hero in my book.
So if we had a Pouilly Montrachet.
And we do.
And we here in Missouri we pronounce that Pouligny Montrachet.
Yeah, Pouligny Montrachet.
Who would make that?
Well, this one that we have is a Etienne Sauzet, and they have been making excellent wines in Pouligny Montrachet for quite a long time. They're near the town of Beaune, which is kind of the sweet spot for for the Burgundies up in that area, is in the northern Beaune area. But you will get both reds and whites from these areas. It's always Chardonnay in Burgundy. Further up in Chablis, you don't get any red. It's a little too cold. But here, you get the cold, the cool climate grapes, Pinot Noir and Chardonnay. These are both Chardonnays. We also have a Jean-Marc Moret, which is a Chasson Montrachet, a little bit to the west of Pouligny Montrachet, basically at the same area though, and they've been
these white Burgundies. Their areas and their wineries and their patches are all about the size of my garage.
Yeah, they are, and in fact, this one I believe this is the Les Carrières. That's actually next door to Batard Montrachet. Next door to that is Pouligny Montrachet, and these are little tracts of land. These are mostly sliced vertically.
Some of the best Chardonnays in the world.
Yeah, absolutely.
They're not non-trivial wines.
No, fruity, oaky, and yummy. And here we go.
This episode of EVTV is brought to you by the Winston Battery Company Limited, makers of high-capacity lithium-yttrium rare earth cells, including the popular 160 amp-hour model featuring cycle lives in excess of 5,000 cycles when discharged to 70%, the longest useful working life of any available battery of any chemistry. A leading battery technology scientist, inventor, and entrepreneur since 1995, Mr. Winston Chung envisions a new world of clean electric power for the dawn of a new era of electric vehicles. For your next electric vehicle design project, contact Winston Battery Limited. Energy for a bright future. Tesla's fighting valiantly to remain in the news. Let's see, I read Elon Musk is going to open up their electronics to applications.
Oh, really?
So you'll be able to write software for the Tesla Model S.
Oh, how cool.
And it not only is cool, I think you got to understand, when I talk about early adopters and tech guys, they're putting in a 19-inch display in a car.
That's what I read. I think it was going to be a
19-inch
monster.
touch display.
Yeah.
Now you can get, you know, GSM circuits and SIM cards and stuff. You have a whole phone in this thing. You're on the internet all the time. You've got navigation. You've got everything about your car. And now he's going to open it up where anybody can write applications for it as if it was an iPhone.
That's pretty cool.
And of course, all of it will interact with your phones too.
Wow.
So this is going to be a gadget geek's car, big time.
You got to love that.
It kind of opened up their facility. They're not being real secretive and stuff. They're touring around with cars. They're building 17 of the alpha models right now. And I've got some photos. We'll put them up here of, it shows their drivetrain, the battery module, the cars under construction. And that's 17. They're targeting the second quarter of 2012.
Okay.
Hopefully to deliver mine. And I remain fascinated by Elon Musk and Tesla. Turns out you were telling me he went out to California originally to go to Stanford and talk about supercaps.
About supercaps, yeah. That was his original draw to the Silicon Valley.
Right down the road at Santa Rosa Junior College last Friday, the 18th, they had a horrible car fire.
Well, it's good they didn't burn down the Sonoma Valley with it.
Well,
that would have really been a rain on my parade.
They did $300,000 worth of damage to the building.
Oh my God.
That
guys, was a fire.
This is serious. It's no longer a debatable topic. This is a fully formed pattern. They burned a car down to the ground, melted the glass out of it, destroyed the building. It's a nightmare, and it's about the 15th one we've tracked. Understand, I don't even care about car fires. We're only talking about fires of such intense heat that it melts the frame of the car, burns all the tires off, usually catches the building on fire, and so forth.
Wow.
There's no, again, definitive cause of the fire. I talked to Chris Jones. He's the president of the EAA out there.
Oh, okay. All right, the chapter
the
up
Bay
there.
Valley EAA.
Okay.
And he's been a consultant to this. He's actually in the telecommunications industry and is an engineer. And he's been a consultant to this project, which has gone on for a couple of years, and whose main theme was safety.
Oh, okay.
Teaching EV safety. And they've had this horrible fire. He's quite upset about it. He indicates that, to his knowledge, the car was not charging at the time and wasn't plugged in to charge.
Okay.
It did use a Brusa charger, which is a familiar name in some of these fires, and an Lithion battery management system.
Okay. Okay.
One of the instructors, supposed instructors of the class, came out this week and said that anybody that implies it's a BMS is absolutely wrong. It could not have been the BMS, and the reason for that was the BMS wasn't even plugged in.
Wasn't the BMS always plugged in?
Well, this guy's teaching this class. The Lithion BMS, and these were installed, have individual modules on the top of each and every cell in the battery. Chris indicated the reason they weren't charging is they were getting a bad indication from the BMS and had shut it off. The control box was shut off, but every cell had a Lithion module on the top of it. I don't know what to tell you. He has no idea what the cause of the fire is, but he's sure it's not the charger or the BMS.
Well, I'm glad they ruled that out.
Yeah. If you don't know what caused it, why do you know what doesn't?
What doesn't cause it?
When you don't even know whether a BMS is hooked up or not. And you're supposedly teaching the class.
The children.
It's Chris Jones was actually a very erudite, and we talked for an hour, and he didn't know, and I don't know either. But I did tell him that overcharging is the easiest way to get one of these batteries on fire.
Yeah.
And he was unaware that there was a fire hazard with overcharging, as it's not mentioned on the spec sheet.
Well,
watch
our show.
Yeah, right. So that would be
yeah. Watch
I've been
our show.
working on another Ziva box. This one's not particularly interesting. It's just like the other ones we've done. A couple of gland nuts, my Ziva to get it out of the weather, my radio-controlled helicopter battery, and a switch so I can independently switch on and off power. The diode we showed you before from our power. But Matt cleaned up my soldering station this week. And
it was a mess.
Yeah, well, it's my mess. And you two should be over there.
We can't stand it.
Neither one of you know how to do any of that, so we'll just stay away from it. Anyway, we lost the little connector that goes on the Ziva. Ian very generously sends us precisely 5 pins.
Oh, yeah, that's right.
And if I drop one, I can't use the Ziva.
No, that's right.
It's not like I can get down on the floor and find it.
Not and get up.
And never get up again. So, Mark Urban of Palm Bay, Florida, one of our viewers, took pity on me and sent me a couple of the correct connector with a pigtail on it. So we're back in business.
Wow,
what
cool.
this is about is I think we can use the Ziva as an input to the fuel computer on the Mini Cooper. And that is my hope.
Okay.
Undoubtedly, we'll try it 12 times before we get it all right. I love this little device. In order to be all things to all fuel gauges, it has to be adjustable. It has no display or really any settings. You kind of calibrate it to your fuel gauge, and you do it in the blind. They just came out with a new documentation, and one of the potentiometers is a 25-turn pot that sets the rate and direction. One half of the pot is one direction, and the other half is the other one. Would you believe all this time I've thought that if you were at the extreme edge of the pot, the furthest from the center, that was your maximum capacity. And as you went toward the middle, it would decline, of course, in capacity until you got the middle and crossed over and started to increase in the other direction. So some gas gauges work backwards. That was a 50-50 shot, and I blew it.
Then you thought the middle was 0.
Right. No, the middle is maximum.
Okay.
And the edges are 0.
And you go out to the edges. Oh, man.
And so we're
well, now we know.
This is actually, it takes days sometimes. You can get this to work quite well with almost any gas gauge, but it takes days of messing around with it because there's nothing to see, and I don't know what to suggest to get well. It's just the nature of the beast. But again, we like the Ziva. Interestingly, Ian and his buddies sell a BMS. So I am actually Satan in that part of Australia. And they just detest me. But he's a little conflicted because every time we talk about this on the show, he's sold out again. You can't get these again. Ian's got to make some more.
He's got to make some more.
You can't buy them until he makes up some more. That's I keep selling him out of these little things. But
it's a great unit.
It is.
Yeah.
I like it.
Yeah.
And I've had several guys on the blog. One of them is constantly trying to get me into a fight with everybody I know. I have no problem fighting with anybody. And I'll criticize anybody and call them to task on anything. It's not like a personal thing. I don't dislike the guy. I don't like what he's doing. I don't like BMSs. So what? You know, there's no personal thing going on there. It's just about hardware and software and stuff. It's what we do. It's what they do.
Yeah.
If I don't like it, I'll mention it to you. Actually, this is a technique developed in the early days of modem development. It doesn't really matter what I think about it. If I tell you that I am enraged, I'm just absolutely apoplectic because they put it in a pink case. What I've done is conveyed something about the device in a fairly entertaining manner, I hope.
Yeah.
You may be looking for a pink case. It's all good. Don't make it weird. I'm communicating a very technical information in hopefully a memorable style that you will be able to absorb without going to sleep immediately. And it doesn't matter what my opinion of pink is. That's not particularly important even to me.
That's right. No,
it's a technique I use to convey technical information. Your mileage not only might vary, I don't even know what kind of car you drive. So it is what it is.
It is what it is, that's right.
I don't take it too seriously, and I certainly don't demonize the individual people. But I will call you out if I think your claim is something our viewers ought to know the truth about.
Sure.
And we're going to do some more of that today.
EVTV Electric Vehicle Systems presents the Soliton1 controller. 1,000 amps of continuous power at up to 340 volts. Enough power to drive your dream car while automatically protecting your precious battery pack. Built-in contactors and pre-charge circuit reduces parts count. Each Soliton1 controller undergoes rigorous dynamometer qualification. An easy-to-use web interface configuration with real-time data logger through an Ethernet connection. The only controller with programmable idle function ideal for automatic transmissions. Liquid cooling for high power operation. EVTV Soliton1. Very dangerous, very high voltage.
Back to you, Chet. Dynamometer testing. If only we knew how to do that.
Well, we actually have a much better idea now. The issue is that there are really no dynamometers that are set up to test electric vehicles. Because one of the things that we're testing, obviously, aside from just the normal horsepower and torque, and when you're putting a regular engine on a gas engine or a diesel engine on a dynamometer, and actually we're much closer to a diesel engine, with an electric motor, is you're looking for what is the point where it's running the optimal, how lean is the carburation or the injection and the fuel mixture and the all the settings on the car. We're looking for something completely different. We're actually looking to put the horsepower and the torque and then graph that with the voltage and the currents to see what our maximum range is. So there really aren't any dynamometers that measure all that and put it together.
And beyond that, there's no precise definition of what a dynamometer test is.
No, not really. Yeah.
We have dynamometer tests for electric motors that are done on the bench. That is a dynamometer to test electric motors. We also have dynamometers to test automobiles, typically gas or diesel.
Right.
Matt was kind of interesting. He came back from the dynamometer test and said, man, these electrics are great. He said, I just, just visiting that dynamometer, I got black stuff all over my face and in my nose and everything from those old oil burner cars they'd had in there. And I kind of laughed. I did, about 12 months. I was on the midway for 44 months, about 12 months on the roof. And it would get in our hair, all over our face. It was just all over you. Kind of a mist of hydraulic fuel and tire rubber. What he was experiencing was you're spinning the tires on that roller actually throws a cloud of rubber particles. And they're very fine. They hang in the air, and they're like petroleum.
Yeah, they're kind of nasty.
Horrible mess.
Yeah.
But anyway, a dynamometer test, we've gone through several versions of this. In fact, we did 2 this week. Originally, my interest in dynamometering a electric car was centered on range and battery capacity.
Yes.
And so what I wanted to know is, in a particular gear, if you were going 35 miles an hour at 1,700 RPM, how much current and how much voltage would that exhibit?
Right.
And that's a consumption.
Right, exactly.
Then I can compare with our available battery pack and see, in theory, how far you would go.
How far you could go, yes.
And would that be different if you were driving 50 miles an hour? Would it take more power in fifth gear or fourth gear or in third gear?
Right, right.
And so that's been our approach to dynamometers. We would get on the dynamometer, we would have them load it for the weight of the car, and we would drive to specific speeds and then maintain those steady state and record what they were seeing for horsepower and torque,
yep,
and what we were seeing for current and
the voltage.
For voltage.
Yes.
I'm kind of in a different phase at the moment. I want to know about drivetrain power and efficiency. And as you know, we're going to be doing a Cadillac Escalade with a little bit different deal. Two Solitons, two 11-inch motors, which are bigger than I'm accustomed, and larger power levels than I'm accustomed to dealing with. And then, of course, an automatic transmission, which is going to pose some efficiency.
Yep.
We're going to pay a penalty. I'm willing to pay it, but I'm hoping it's not much.
Right.
It could potentially be much.
It could be a lot, yeah.
And so that's what we're looking at. As a result, this week we went to a different kind of test. And it's not much different, but it's a world different.
Yeah, it is a different test.
And in this one, what you do is mount the dynamometer, bring it up to a couple 300 RPM so that we don't throw the car through the door. And then they apply a heavy load of about 5,500 pounds to the car.
Yes.
And a brain here floors it.
Yes, that's fun.
And the car accelerates not very quickly, I would guess. How long did it take?
First and second, it does.
Pretty quick.
Yeah, in fact, if you look at the dynamometer tests when we show them to them in first gear and second gear, it looks like we didn't start till about 12 or 1,500 RPM. That first few hundred RPM is actually the car squatting down on the dynamometer. Instead of spinning the rollers, it's going straight down as the suspension compresses. And it looks like we messed the test up, but we didn't. The car was not moving forward, it was moving straight down from all the power that we were applying.
Well, good. The point is that he puts the pedal to the metal, and the dynamometer accelerates from the 200 or 300 RPM up to, what were you all hitting, 5,500?
Yeah, 5,500, yeah.
And this happens pretty quickly, not as quickly as it would be on the road because you got twice the load.
Right, yeah. And third and fourth gear, it takes a while to wind it up.
And what that does then is, if only the machine, the dynamometer machine, records the continuous curve, the horsepower and the torque across the entire RPM band.
Yes.
And he can go to any point on that and read that off to you, right?
Exactly. Yeah, any like a, any RPM range.
So then we're going with the pedal full down the whole way, full power.
Right.
And so then what he does is goes to the data set and extracts the RPM, the torque, and the horsepower for any given speed, and we just pick out some arbitrary ones, but you'll find them familiar. I like 10 miles an hour,
that's what
20 miles an hour, 30 miles an hour, 40 miles an hour, and 50 miles an hour.
Yes, that's what we were using.
Then it gets tricky. Because this is sort of one smooth motion, we will need a current measurement. And we have a tachometer, but it can't display current and RPM at the same time.
One or the other, yeah.
And we have an eVision, which does display current. And he had a Snap-on Tools multimeter thing.
Yeah, it's the Vantage or Advan, I think the Vantage, and we're going to try to track one down. It's pretty cool. It will display, at least the one he had was an older model, and it has these actual modules that you plug into the head end that has a display. And this one, he plugged in an ammeter that had a nice Hall effect that he could snap around it, and it went up to 999 amps, which is exactly in our range. We were looking for 1,000 amps would have been
well, I
our
would
top
like
of our
for it
range.
to go up to 999, as we'll see here shortly. It didn't. But,
Yeah, it did.
so he hangs that on the dash, and we videotape it.
Yes.
Now we have to go back in the video and find each place where we hit that RPM.
Right, each RPM increment, yeah.
And copy down the voltage and the current displayed at that point.
Exactly. Yeah, we had to true those two data sets up.
And the purpose of all this is a max power
Right, that's our max
dynamometer
power
test,
run, yeah.
with the pedal all the way down. Let's show them you guys in action over there.
Okay, it's pretty cool. All right, Jeff, so we're back out here at Sling Blade Performance with Jeff Lentz. And if you guys didn't watch the previous episode, then you need to go back in our archives and check out the first time that we ran the Speedster out here with the 9-inch motor, but we ran it with the Kelly controller. We had 120 volts. So what we're going to do now is run it with the 192 volt, 180 amp hour batteries. We've got another 9-inch in there, a Netgain 9-inch, but we've got their newest motor with all the brushes and everything. We'll see what that does. And we've also swapped out that Kelly controller for the EVTV. So we're going to run this thing today and just see what in the heck it does. So what are we going to be doing on the dyno, Jeff? Tell me exactly what we got going.
Well, we're going to compare, when we get this thing fired up, compare it to the last time.
Okay.
See what kind of differences you have. Should be able to do the same thing, you know, at each RPM, and
right.
see the differences at each RPM, and
okay.
hopefully we've made better.
Yeah, and that's what we're really looking for, just to see what in the heck the difference was. I mean, we obviously spent a few pennies to make this happen. One other cool thing is, last time we trailered it out here. This time with the range, we drove it out, and it was about maybe 25, close to 30 miles from Cape. And I think we took out maybe 30 amp hours about, so about an amp hour a mile. We know we got 30, 35 on the way back. So we should be able to run this up on the dyno and not have to charge it, get it back to Cape this afternoon. And we'll keep you posted as far as what's going on. So you ready to roll?
Yeah, looking forward to it.
All right, let's do it.
All right.
So Jeff's got us all strapped in. You can see the tie downs are ready to go. He's setting up the computer right now. I also got our, on this car, it's pretty easy to pick up the RPM because we have the auxiliary shaft with this Netgain 9-inch. And when we calibrated our tachometer, we wanted to see, you know, how far off, and we were, you know, right on with the tach in the instrument panel. We put an optical piece of reflective tape on there that has a background of black tape. And we could check that with our handheld that we have at the house, the RPM. Jeff has an optical sensor here, so he's got it on a magnetic base and got it where it's going to be picking up the RPM. So we'll be able to do the torque as a function of the data that's coming out of the computer for the dyno, and we won't have to do the calculations by hand. So it makes it a little easier to do that with this car. So a couple minutes here, we're going to start running this. We're going to get run through all the gears. So we're going to run first, second, third, and fourth gear. We're going to run every 10 miles an hour. We're going to get the RPM, the torque, the current, and the sag voltage. And we'll go ahead and generate some data for you and let you see how this vehicle does.
10, 11, 13, 15, 17, 18, 19, 20.
Okay, I'm gonna keep going.
23, 25, 26, 28, 29, 29.
Got it?
30. 33. 35. 39. 40.
'Kay, that's it then. 'Cause that was about 6,000 RPM. We can break it. Yep. All right. I'll let it cool for a second. Just make sure. Let's make sure. Why don't you set up a different spot?
Netgain Motors, home of the Warp, Transwarp, and Impulse motors, introduced the improved Warp9 motor. The Warp9 is a 9 1/4 diameter series wound DC motor with a double-ended shaft featuring 26 improvements for 2010. Externally, the terminal studs have been enlarged from 3/8 to 1/2 inch diameter. Bigger is better. On the inside, a larger commutator, new brush composition, and split brush design with heavier springs handle even higher voltages and currents than before. Our new fan increases airflow by almost 50% over typical paddle-style fans. And all this translates into improved performance. For even more performance or larger applications, take a look at Netgain's Warp11 motor, an 11 3/4 diameter series wound DC motor for even greater torque and power. Since 2002, Netgain Motors has been leading the EV industry with precision, performance, and price. Visit us at go-ev.com. Netgain Motors, warp power to go.
All right. So we're going to start here then. Our second gear runs 10 miles an hour, and then Jeff's going to call that out, and every 10 miles an hour after that. So now that it's in second gear, let's go ahead and do that again. That feels better.
Ten, 11. Let me slow you down a little bit.
Okay.
12, 13. It's going to be really hard to do 10 mile an hour, I think.
Yeah, I need to be about 1,000 RPM. Sorry.
There's 7, 8, 9, 10.
Okay.
$20.
20?
Yep. $29, 30. 34, 35, 36, 7, 40.
40?
Yeah. 48, 49, 50.
Running? All right.
Good.
Got it? Oh, okay. All right. Got it. Okay. Okay, so now we're going to do a full third gear one, huh?
Third gear pull. Yep.
Okay, and I'm in third. Okay.
Okay. So get her rolling there, 1,000 RPM.
This is our second gear run. The first second gear didn't really count.
Are you ready?
Yep.
Go ahead.
Okay, this is our third gear run.
Yeah.
Okay, this is going to be our fourth gear run.
Okay. All right.
You're good?
Just sort of slow your information down too.
Yeah.
Actually grab it, you know. Okay. Anytime you're ready.
C700 on the.
Okay, so these are the latest runs then that we're doing?
This is the last run you just did.
Okay, so this was an all third gear run, or was this the second and third?
This was a second and third.
Okay, so this is a second and third gear run that we did here, and we got, what, 171 foot-pounds of torque out of this thing.
Right.
That's not bad.
We also reduced our quarter mile, what we're going to call our rolling quarter mile.
Okay.
We reduced it by
By a second?
and a half.
Okay.
Because we were at 16 and a half before.
Oh, and we're just about 15.
Yeah.
Nice. So
So second to third is quicker than
first, second, and third. Yeah.
No doubt.
Yeah. And we had run this thing with one of those the little G-Tech units, you know, the kind of drag strip in a box, and that was what I found with that too. Was
About a 14 and a half second quarter mile. Or
you know, I don't remember, but that's nice, 14 and a half. I don't remember, but I remember it gave me the shifting, you know, the taking off in first gear. So we did what was our top speed then?
About 89 miles an hour.
That's not bad. 14 and a half at 89 miles an hour.
That sounds about
That's about right.
You know, I mean, that sounds about right.
And that would put us, I guess, in the class of what kind of cars are doing 14 and a half second quarter miles thing. I mean,
brand new Camaros.
Yeah. Brand new Camaros.
Volkswagen.
All right, baby, bring them on.
I don't know if they'll. That's a dyno race. That's not on the road, but.
Oh, I mean, better on the road.
I think you might be better on the road. You weigh 1,000 pounds less than they do, so.
Okay. That's great.
Yeah, that is pretty neat. 14
Well,
and a half.
and then we go and
Engine speed. You know, you're really only spinning this thing up too. Both of those runs, you know, under 5,000 RPM. You're not even really breaking 5,000 RPM.
no, and that's where I tried to shift from our last demonstration that we
Right.
saw about 4,200 was the max.
And it still is at 4,200. You're at your max. So really, if you were to go to shift from third to fourth, and you were wanting to, you know, produce your most power to the ground, you would want to shift this thing around 4,200.
4,200, just extend
After
that out.
it's still making power, but it's not making it like it is at 4,200.
Right, right.
All the way down to the beginning.
Right, all the way from basically dead stop or
Right.
rolling start, yeah.
Right.
Okay.
That is what is different about looking at this dyno graph versus a gasoline engine's dyno graph is unless it's maybe a turbo diesel, it's not going to give you a steady torque curve from start to finish. It's
Right.
gonna-
It's going to have
it doesn't
a climb and a
It's got-
peak.
It's got just a flat line.
Right, it really isn't a curve.
Right.
Yeah, it really is
RPM
flat.
doesn't affect torque on an electric engine as much as it does
On
on
a
a
gas engine, on a gas, yep, right, okay. Well, cool. Well, I guess we've got some really good information, so we're going to recap all this and tell you a couple things that we found. So we have got a car that can make it back to Cape Girardeau. Last time we drove it out to 25 miles here and did the dyno, had to put it back on the trailer.
Yeah, that'll be nice.
So what do you, and we had some guys come by and take a look at it. What did your customers think?
Oh, I think they were well impressed, especially the one that works for Ameren.
The one that works for the power company seemed to like it. You see, we've been trying to talk to our local power company about doing something, and they were talking about doing in Missouri a kind of an electric vehicle test station. We've been trying to convince them to do it in Cape Girardeau, but we haven't even been able to convince them to do it at all. You know, the phone, it's like the phone company, you know, the power
Right.
company.
Yeah.
But I appreciate it, and
No problem.
we're going to get all this data on a disc and look at it and get it up for you, and you'll be able to see what we did today.
You got a lot of information to go through, so.
We did, and we're going to bring the Spider back. Spider's never been on the dyno. We're going to put that on the dyno and with the 550 amp controller, and then we're going to take that back home, and a couple days later bring that back with a 650 amp controller and see, we'll be able to compare kind of apples to apples in terms of just one change, just the output of the Curtis 550 amp to the 560 amp. So we'll see what we get there.
Okay.
We appreciate it.
Thank
All
you
right,
very
buddy.
much.
Thanks
Always a
again.
pleasure.
Okay.
Well, it looks like you all were having fun.
We were. It takes a while. I mean, it's hours of fun, but it is a blast out there, and it takes an extra couple of hours for everybody that comes in out of the other end of the shop that wants to see the electric car and how fast will it go and how far will it go on a charge. I should just put that up on an easel and leave it on the outside, and then I wouldn't have to ever answer those questions again. But that's what most people out there are interested
How
in.
fast it'll go,
And how far will it go? Yeah.
well, do you tell them on the dynamometer it doesn't go very far?
It doesn't go, it just stays right there. Yeah, it's just
Kinda
kind of,
anchored down.
well, we did, one of the straps did come off during one of the dyno runs. It was kind of interesting. It didn't go far, maybe an inch, but it slowed us down a little for a second.
Let's talk about the results. I can't make this out. I'm even afraid to draw any conclusions from this. I'm going to put these results out here, tell you what I've been told, which I can't quite buy, and then we have an open question and welcome all input. First, let me give you our Soliton1 settings, because they have a big impact
Oh, yeah.
on what it is, and I'll tell you what I think they mean. Our first one is power mode. I have that set for performance.
Yeah, so it's a little noisier.
Performance is a slightly more efficient 8 kilohertz of square wave in the controller. It's annoying to a lot of people, and so they have a quiet mode.
You do hear it.
That's 14 kilohertz, and by the way, works fine. But it's slight
slight
not
advantage
much,
for
but
having performance. Yeah,
little better switching losses at 8
at
kilohertz.
8 kilohertz. Yeah.
Our minimum battery voltage we have set to 100 volts. Our pack is actually 192 volts. I guess by the time you drive to Anna, maybe 188.
We'd start to test at we did start at 191, work our way down to 188, 187.
Mm-hmm. Okay.
Yeah. But we never sagged below 100 volts. We were never even got close.
Well,
no.
and the reason this is important, we did sag down into the 150s.
150s, yeah.
I never saw a 140.
Yeah, 150.
And if you did have this set, for example, at 160, as you put the pedal down, and when it reaches that 160, the Soliton will limit current so that it doesn't go below this 160. This is to protect your battery pack. All controllers I've seen have this feature, and it's totally useless and often damaging. And because people will set it for a value, not realizing their batteries sag that far, and never do get maximum power out of the controller because it puts out current until it gets down to that level and then maintains it. So it's working fine. You just never do get
governing
quite. Maximum battery current we have set at the maximum of 1,000 amps, and therein lies the tail. Maximum motor voltage. Again, I've got it set to something it'll never see 195 volts.
No. We're at 190.
With these new Hellwig brushes, I think we can do the 191.5 volts, which is our maximum we're going to be able to exhibit. Maximum motor current, 1,000 amps. I'm going to talk some more about that in a minute. The maximum motor power you can have set to anything that will limit the combination of current and voltage to the motor to a kilowatt, a value, a maximum of 300. We have it set at 300.
Okay.
The slew rate you can set from, I think, 500 amps a second to 25,000 amps a second. This is how quickly, if you put the pedal down, that the controller will ramp up the power.
Okay.
And in this case, I have it set to 5,000 amps a second. Now, we don't have 5,000 amps, so to get to 1,000 amps at 5,000 amps a second would be 200 milliseconds.
200 milliseconds, yeah.
And this is where you can keep your controller from very suddenly applying power that would be damaging to your drivetrain components.
Yeah, absolutely.
The maximum motor speed is 6,500. We traditionally think of 5,500 as our limit on the net gain. George mentioned this week that they, in some racing applications, have had them at 8,000.
Yeah, that's
we're not going to go there, but we set a fairly liberal 6,500. The first graph I'm going to put up here. Let's start with first gear. And I'm going to put I'm working off a sheet of paper, but through the miracle of video editing, I'm going to put this up where Brian
right over
is.
me, I know.
So
see you guys.
Can't see Brian. Brian's out here.
You can only hear me.
And we're going to talk about this. This is our first gear dynamometer test. At the top, I have voltage. There's two scales. On the right is 0 to 200, on the left is 0 to 600. The left is just there for current, and your red graph item shows the current. The topmost element is voltage. I think we're starting at 179 on this graph with the voltage. The next one down, the dark blue one, is foot-pounds torque. And then below that, we have our amperes. The dotted line is your efficiency, and I'll talk about that in a moment. Below that is horsepower, actually, and below that is kilowatts. The voltage, of course, is what we measure, and it will sag as you take current out of it. And our current, of course, at 2,600 RPM and 20 miles an hour, we're doing 352 amps and 179 volts. By the time we get to 3,930 miles an hour, we hit our peak of 572 amps and our lowest value of 169 of voltage.
Sagged at
So
that point,
as you take power out of the batteries, the voltage does sag considerably. Foot-pounds of torque. Torque and horsepower are what they measure in the dynamometer. And let's go over here on the whiteboard and let me see if I can make up a formula, and I'll come close, and our viewers can then write to me on the blog of what I did wrong. But I believe if we will take foot-pounds and multiply it times our RPM and divide that by a magic number that I'm not going to go into how it's derived, but it is derived. It represents 3 or 4 other things, that we wind up with our horsepower. And let me get my magic calculator here. And I have, at the peak, and this RPM comes up over and over again in this test, 3,900 RPM is our peak value here. And so if I take 3,900 and take our foot-pounds, which happens to be 149.74, and I multiply that by 3,900, I'm going to get 583,986, and I divide that by our magic number of 5252, and that gives me 111.19 horsepower. And if I look on my magic sheet, I get a 111.2 from the dynamometer. And that tells me I've probably got a pretty good value there. That's pretty close. In any event, that is the formula for the relationship between horsepower and foot-pounds at a given RPM. Horsepower is actually derived, foot-pounds is a unit of force, and RPM is a rotational speed. And we have to have both of those to come up with a horsepower figure. And it will vary by RPM. Let's talk a little bit about what else I've got on the magic graph here. So we've got the relationship between voltage and amperes. Actually, that is our input power. And so if I had, again at that 3,900 peak, 572 amps times our 169 volts, that gives me 96,668 watts, and I'm counting that as 96.7. There is also a value, there's 2 values actually for horsepower. Mechanical horsepower to watts is 745.699 per horsepower. Electric motor horsepower is rounded off to 746. So we're kind of comparing to the mechanical output of it, so I prefer to use the 745.699. If I divide that kilowatt value of 96,668 by 745.699, I get a value of 129.63 horsepower. And 129.63 horsepower is a little bit more than the horsepower we measured at 111.2. Okay. How do we account for this? Well, actually, we're putting in an equivalent amount of power for 129.63 horsepower, but we have losses in the controller.
Sure.
We have losses in the motor.
And the transmission.
We have losses in the transmission, and as Matt learned the hard way, we're even spraying a little rubber.
We're spraying a little rubber, yeah. There are losses everywhere.
So if I take our 111.2 and divide that by 129.65, the horsepower equivalent of our input power, I get a magic number, 0.8576. And you know what I like to think of that as? 85.76% efficiency. I'm getting out 85% of what I put in.
Ultimately, through everything.
And so I have about a 14% loss.
Yeah.
And that's what this efficiency dotted yellow line is. At the bottom of the graph, you'll notice that we have 3 speeds and RPMs. 2600 for 20 miles an hour. 30 is 3900. 40 is 5100. Now understand that we're doing this at a continuous rate, and about 40 miles an hour, we're up over 5,000 RPM and have to discontinue. Yeah. We've arbitrarily picked out 20, 30, and 40 miles an hour as being something you could relate to in a car, as being the points that we're plotting. And this is not a continuous graph. We're just plotting those points.
Just those points, right.
If we went to second gear, things get a little more interesting, but they still peak probably about 3,900. 40 miles an hour is 3,700. 50 is 4,600. And so we actually have a maximum value that's higher than what's shown on the graph, because we didn't graph at the 3,900, which is where we would normally peak. With this system, 3,900 is our magic number at this voltage. But you can see the same relationship between voltage, torque, amps, kilowatts, horsepower, and efficiency. And it looks to me like we're doing about 574 amps at 4,600, 127 foot-pounds of torque, 111 horsepower. If we go to third gear, it's somewhat similar, although you notice third gear is really kind of our best gear.
That's the sweet gear for us.
We've got a long, flat torque output, culminating at about 163, 164 foot-pounds.
And it puts it on right away.
118 horsepower. We can go from 20 to 90 miles an hour in third gear.
We can.
We're really done now.
That's everything you need, yeah.
We don't need a fourth gear.
No, we could fine-tune third gear probably a little bit and get a little more out of it, and that's our perfect gear.
Fourth gear is our tall gear. We recorded, again, at 4,000 RPM is 90 mile an hour. And that was 722 amps, 125 horsepower, 164 foot-pounds of torque, and all is right with the world. And we'll put that up there and let you look at it. Our efficiency wanders around a little bit, and that's actually kind of real world. Things vary depending on RPM and load.
Right.
I've got 2 additional graphs. I find these interesting, kind of back to driving.
Oh, okay.
If you look at our dynamometer horsepower graph, I've got all 4 gears on one graph.
Okay.
And so you can see that about 30 miles an hour we peak out in first gear. It starts to decline, but I would say 36 miles an hour, second gear picks up.
Okay.
And so that goes out to maybe, second gear, you could be over 55 miles an hour. It's dropping off, and third gear picks up. This is kind of your shift points.
Your shift points, yeah.
For optimum operation. Third gear is good out to 83 or 84 miles an hour. and from there you need fourth gear, which is why we call fourth gear in this car the felony gear. It's we use that 3.44 ring and pinion,
right,
and some tall.
That's a .93 fourth gear. That's an overdrive fourth gear, and it takes the car. It took the Speedster duh, and now we've had that same gearing in the Redux of the .93, and it's 130 miles an hour. It takes a lot to get there, but it's 130 miles an hour on the dyno.
Now I've done these at speed because I wouldn't have a common axis for RPM.
Right. Right.
I might be able to do that, and I probably should have done that on this one, which is a graph of dynamometer torque from each of them. And you can see that you build torque going out in RPM or speed, and then it will drop off rather sharply. Mm-hmm. And this is the nature of these electric motors, and it's pretty much all of them. When you hear about an AC motor that does 11,000 RPM, about 4,000 RPM, it starts to drop off.
And you can feel
just
it,
like these. And that's kind of a function of your applied voltage more than anything else. You can move that point. We're at 3,900 or 4,000 RPM. This car, when it was a 120 volt car, it was more like 3,600.
Yeah, it was under
or
that.
3,500 was the sweet spot.
Few hundred RPM.
So you can move that a little bit with voltage. What it is at some point, the motor's spinning fast enough, it starts to generate a counter electromotive force.
Yeah.
And that's called a back EMF or back electromotive force that you're kind of balancing out with, and your resulting power starts to drop off dramatically. Now, what happened to my 1,000 amp controller? I was told that this thing was capable of 300 kilowatts and 1,000 amps. Brain, how come you didn't bring me 300 kilowatts back from Anna?
You know, I must have left them in a lunch bag or something on the side of the road because I never did see them.
You never did see those, did you?
No, and I worked pretty hard. You know, at one point put the car under a fairly big brake load on that dyno at full throttle and only got it to decrease RPM. I could not get it to get up there to 1,000 amps. I probably spent, I don't know, half an hour trying to get it up there.
I've got a graph here of your data you did bring back that shows me 722 amperes.
We're going to 752, I think, right? Or 722, yeah.
722 on this one.
Yeah.
That was your max. You did that, well, that was a couple days before that. This was 20 degrees cooler.
It was.
And a little lower. It was 722 amps at 154 volts.
Okay.
And my magic calculator shows that as 111,188 watts. And that sounds an awful lot like 746, 149 horsepower.
Okay.
And indeed, we got out about 125 horsepower.
Okay, to the rear wheels.
Mm-hmm. Now, I did have a conversation several weeks ago with Jeff Jenkins. He said that he had an online calculator that showed that a vehicle of our weight with a manual transmission and this much power should do a 0 to 60 in 6 seconds. And I said, well, Jeff, we were getting 10. And we were. You all kind of moved your shift points around a little bit, got it down to a 9.00.
Yeah, got down to 9.
Now, the reason we're at 9.00 is we really have 125 horsepower here.
Yeah, to the wheels, yeah.
Well, I thought the Soliton did 1,000 amps.
Didn't see it.
You know, when we were on the test bench the other day, their logger program was showing a amperage value, 189 amps or something, and we're reading, 80 amps for the two of them. There's been a couple of explanations for this, and I've got to say I don't buy any of them. And then I heard that the whole industry does this, and I didn't really buy that. We know with the Thames 600 and the Reinhardt motion control system, and in fact with the Curtis has a 550 amp limit on their specification for their controller. I've seen 575. The Thames 600 has a 300 amp limit. I've seen 365 amperes, sagged to about 345 volts, and they have a 400 volt limit on their controller. The Reinhardt motion system is supposed to be 300 amps. I've done 325. It is less power than the Thames, but it's a pretty good system. But somehow it's different in DC land. Now here's Jeffrey Jenkins' description of this. This is our pulse width modulated waveform. And if we do 1,000 amps here at a 50% duty cycle, we have on for, let's say 20 milliseconds and off for 20 milliseconds. It'd be a 50% duty cycle on our square wave. That then, if we had 1,000 amps on the waveform, that's 500 amps from the battery. And this accounts for this. And that's where it's a 1,000 amp controller. I'm interested in maximum power. When I have the accelerator fully down, I expect to see a waveform that looks like this. It's 95 or 98% on and 2 or 5% off. And at that point, there is no difference here. We're basically, during this part of the waveform, simply connecting the battery to the motor. And my power is a function of where that voltage sags to, in this case 154 volts, and where this current goes to, in this case 722 amps. And I can't seem to get this controller to go over that. We have seen about 755 amps at the very maximum. So I can't resolve this magic explanation of motor current and battery current. Somebody help me because I don't buy it. At some lesser duty cycle, yes, there's a relationship. If I put in 200 volts and 100 amps in this, sure, I could put out 200 amps and 100 volts. It's going to be the same amount of power. Your current would vary. I believe that Mr. Jenkins has sold his partners on the idea that it's a 1,000 amp controller based on his ability to switch 1,000 amps in the IGBT. And I reject that explanation out of hand. It's not a 1,000 amp controller, it's something, but whatever power I put in that it'll take and apply to the motor is the limit of the controller, and right now that looks like about 750 amps. His partners, 2 of them, have come to me with completely different explanations. Seb's is kind of interesting, and that is that I'm not loading the motor enough. I don't think I need to load the motor. I've got wheels that are spinning relatively freely. When I press that accelerator, I want the 100% waveform. practically a 98% or 95% waveform, and everything my batteries will put out. I happen to know these batteries will do about 3,000 amps continuously. David Coy took a 100 amp version and drew 2,400 amps until it was 0 volts. By the way, it got warm, but not really hot. He could still hold the battery in his hands. So these batteries will put it out, and I'm just not getting 1,000 amps, and I'm not going to get 300 kilowatts in any event. The 300 kilowatts would be at 300 volts if I could do 1,000 amps. For me to do 1,000 amps out of this battery pack, you're probably looking at 145 or 146 volts at 1,000 amps would be 145 kilowatts. And that's what I was looking for, was something in the 175 horsepower range. 145,000 divided by 746 would be 194.37 horsepower. And I think this car would do a 6-second 0 to 60. Were I getting that? The truth is, I'm not getting it because I don't have a controller that'll do it. It could be that I've got something configured wrong, which is why I called them and emailed them and sent them the graphs. I do that sometimes. And we've done this over and over, found out later I had something set wrong. That's why I gave you our Soliton settings. If this will do 300 volts at 1,000 amps, surely it'll do 145 volts at 1,000 amps, and that's all I need to be pretty close to 200 horsepower, but I'm not getting it. And it's not, Seb, the dynamometer's fault. If I press that pedal to the metal, I ought to get what I'm going to get out of your controller and that battery pack to that motor. And it can either blow up or give it to me. That's its two choices. That's how electric motors will work. Yeah, we're rated at a 52 horsepower motor maybe, but that's a 1 hour rating. If I can put enough power into it, it does exactly how much power I put into it up to the point where the smoke leaks out, at which point it doesn't do any at all. But for some period of time, I should be able to get this 194 horsepower out of that motor. It wouldn't be for very long, but certainly a minute or so, a few minutes. And so I think this controller is slightly oversold at 1,000 amps. And for all of you wanting the drama of another feud, it'll further surprise you when I tell you I really like this controller. It works quite well. It doesn't do what they told me it would do. I don't guess they invented that, did they? And maybe it does. I could be wrong. That's why I've shared all this data. I'm going to put all these graphs on the blog.
Help us out.
And our settings on the Soliton1. I would like to have 200 horsepower here.
Because then I think we could get down to that 6-second 0 to 60.
Show me how I can do it. I do not believe the batteries are the problem. This is a strong pack. 5,780 amp cells is just pretty strong.
Yeah. Yeah, that's crazy. That's crazy pack. It's ridiculous.
And this motor, now I get confused between the first run and the second run. Did you feel the motor after the second run?
What do you mean?
Did you feel the temperature on the motor?
Oh yeah, no, it was. I think it never got above. Christ, what did we measure?
The first one was 140.
140. Yeah, I mean it was. Yeah, that was absolutely the highest that we ever got, and that was when we were on extreme load doing our load runs. Yeah, that motor was not even close to overtemping.
How about the Soliton?
Soliton was running cool. I think we got a reading of 98. It was like body temperature.
98 Fahrenheit?
Yeah.
We've got a great little liquid cooling system.
Yeah, that cooling system was really good.
I guess I think this thing doesn't even need a cooling system. I think the fans and the fins are doing fine. Obviously, the temperatures are higher
Yeah.
at the IGBT than they are on the fins, but this wasn't body temperature after this run.
No, it was fine. And I mean, whatever.
Now, we're pumping a bunch of glycol through there,
Yep.
but our heat exchanger isn't getting any air through it on the dynamometer.
No, none at all. And the fans only came on at the bitter end of the last run. So whatever they're set at to come on, they finally did come on, but it was very briefly at the very last couple of runs.
The thing I keep coming back to, Brian, is whatever people say and whatever they think, I think we've actually got 4 or 5 people in this Evnetics thing all in violent agreement on 3 or 4 different things.
Yeah, I think so. Yeah.
I don't think internally they're talking the same way.
They might not.
I get one explanation from Jeff Jenkins. He's furiously with me for insinuating that they should be talking about anything but motor current as somehow different. Jeff, nobody cares about motor current. We can put power into a drivetrain and we get resulting power at the wheels. I'm interested in both of those. What else is going on in there isn't even of interest to me.
No, it would be academic if anyone cared.
Well, Seb says this is not rocket science. I said, Seb, technically 3 years on the multiple targetable reentry vehicles, a little bit of bookwork on the Venus radar mapper, and then I did do the proposal on the manned Mars mission while I was at Martin Marietta. I kind of was a rocket scientist. This concept that once you're an engineer, you know everything is absurd. And I get things backwards. It could be entirely possible to be a rocket scientist and know nothing about controllers, which indeed may be the case here. Maybe I just don't understand it. In my world, if I push that pedal to the floor, I should get 100% power out of the controller that it will do. And I happen to know this battery pack will do more power than that.
Yes.
So
that battery pack will do a lot more.
Show me where I've got this messed up.
Masterflux proudly presents the Sierra Series brushless DC variable speed electric compressors. The Masterflux family of compressors are up to 40% smaller and lighter than competing belt-driven DC automotive compressors. Masterflux uses rare earth neodymium magnets for longer life and greater efficiency. The robust rotary design is ideally suited for rugged EV applications. With a scroll-type compressor, the process begins with refrigerant entering the evaporator from the suction side. Refrigerant then travels through a reed valve to the top of the compressor, where it is compressed at up to 8 times the incoming pressure before exiting out the discharge tube to the condenser. Masterflux compressors are available in 400 to 15,000 BTU per hour capacity range for multiple refrigerants, including 134A. Output can be manually adjusted using a simple 0 to 5 volt pot. Masterflux compressors are available to handle input voltages of 12 to 420 volts DC and come with a specific BLDC motor controller for each voltage range. The new Masterflux 2011 product catalog can be downloaded from their website at www.masterflux.com. Masterflux products are available in the US from Revolt Custom Electric Vehicles, in Australia from EV Works, and in South Asia from EV World. Masterflux, the technically elegant choice for powerful electric air conditioning.
The contest.
Yes.
Everybody's wanting to know about the contest. Mea culpa. Should have been done a month ago. Let me tell you what's happened. I don't know whether to laugh or cry. I know something you don't know. Na, 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 na. I've been working 2 or 3 hours a morning on this, guys. I'm on page 240 of 880.
There's 800, almost 900 pages.
Some of these guys on the entry thing went 7 pages of text at 12-point type.
Yeah, we should probably limit the characters for the next giveaway.
I'm not going to limit anything. Right? Apparently some of the people thought this was like a random drawing or something. It never was.
No.
We asked you a bunch of stuff that our advertisers might want to know, or we might not want to know. The whole contest is about the last 2 questions. What do you want to do? And why do we want to send you batteries to do it?
Yeah, that's really it. Yeah.
And it's kind of an essay question. And a lot of people got with the program. I've got
there's some
880
big ones.
pages of printed matter to go through.
Yeah, I guess that means they've been watching the 2-hour videos. They figured if we can dish it out, we must got to be able to take it.
We better be able to take it, fat boy.
Right.
We're going to listen to you for 2 hours.
Yeah, it's like,
yeah,
here,
you
check
got
this
to
out.
listen to me. Fair enough. I'm on board.
Yeah.
No, I like that.
Yeah, check this out.
And I'm doing it.
Yeah.
Unlike a lot of commercial entities, I have put up this contest, put up this thing. They went to the trouble to fill it out. I'm going to read every single word.
Every single.
If it kills me, and right now
It's killing you.
it's killing me. That's the bad news. So it's going to be another week or two before I can get we're going to pick 100 of them, and not entirely based on length.
No,
but
substance for sure.
But substance for sure, and every single entry is going to be read by me, not delegated. And then these two guys are going to have to read them and pick. But they can just pick out 100. I actually have to read every word of it. But they can just simply pick out 100 of you at random or however they want to do it.
Photos of your dog.
And then we're going to kind of compare that and come up with 100. Send that to our sponsors, which is Netgain Motors, EVTV, Masterflux, and
Recharge Car.
Recharge Car. I don't think Stag Beer's going to read them, are they?
They may. We might be able to get. Maybe our local distributor will.
Yeah. And they're each going to pick out two. Now, I mean, all entries are not created equal. Some of these just jump out at you, so there could be dupes among our sponsors.
Right.
We're going to pick out however many then as necessary to come up with 10 unique ones. And Christopher Fisher's been hard at work on a presentation methodology on the web.
For the web,
and we're going to contact the 10 and let them send in photographs, videos, more text if they want. And we're going to put these up there where you can then review them all and vote on the winner. And this will be pursued to completion. The slow up is I'm actually going to read every word of every entry. They thought enough to write it, and by God, I ought to read it. And that's just what we're going to do.
And we found Matt's.
Now, what is it I know that you don't know? Yeah, we do. Matt's
we know who Matt is.
He's busted.
He's busted.
So, and he's not going to be in the 10. What is it I know that you don't know? I read page after page of this, Brian. I am utterly astounded at the innovation and the creativity of the people that are watching this show, but more to the impassioned fire of this. Yeah. They believe in electric cars and our future oil-free to a level that I don't think any particular one of them is aware how many other people feel that way.
Feel the same way,
and to what degree.
Yeah.
Most of them think they're sick with this.
Yeah. And they're the only ones.
And they're the only ones.
Right.
I'm the only one that knows now that there's hundreds of them absolutely committed to this. They want this to be their life work. They want their own businesses doing this, or they'll work for somebody doing this, but they do not want to do something they don't care about anymore. They want to do this.
Yeah, this is it.
And they do care about it, and it's intense. It makes the internauts look like a bunch of part-timers. And remember how that religion was pretty wired for sound. This, I've never seen anything like this, and I'm probably the only one in America that knows what's going on at that level.
Yeah.
It is intense. When you read these, it's going to hurt you. It hurts to read this. The EV Electric Vehicle Conversion Convention.
Oh, yeah. It's starting to take a little more of our time than we thought.
How do you get me into this stuff?
It only ever works out for the good, Jack. I'm sorry.
You are damn good at spending my money.
You just come.
Oh yeah, let's have
you
a
come
meeting.
kicking and screaming,
Like
but you do come along.
Like a build school. We'll have
Yeah.
a few people come in and we'll
Yeah, something small scale. Yeah, no
cater
big
some
deal.
lunch, talk about batteries, show them some motors.
Yeah, sack lunch.
This would be fun. Just here in the shop.
I think I bullshitted you a little bit on that. You believe me?
3 weeks into this, we have 37 people signed up and 12 cars coming.
Yeah, baby.
I got the money.
Yeah. No, those, yeah. Well, 38.
That's right. You got one on the desk.
Yeah. We don't know what to do yet with a check. But you're in.
You're in. We'll figure out a way.
Check sending dude, you're in.
Okay, so now we got to do a show. I am excited about it.
It is exciting.
I was really in a panic. We checked with a couple of the local venues here in Cape. The AC Braze Arena has a wedding that day.
Yeah.
The Show Me Center, which can do 7,000 people, they have the gun show.
They have the gun show.
The whole weekend.
Yep.
And I'm getting in a panic. Brian finally told me, well, Jack, you got an 18,000 square foot convention center down at the airport. Oh, yeah, I do.
We just have to move the planes out.
The planes out, but sure, we can do that.
Yeah, we have our own convention center.
And in fact, there's about an acre of concrete in the front. We're talking now about a slalom course and maybe do some quarter miles.
Maybe some quarter miles.
And speaking of dynamometers, and I never really did finish that, what we're going to do. But Brian thinks he can find somebody with a mobile dynamometer trailer to come in and let everybody that brought their car get a printout of what it'll do.
Yeah, at least get the horsepower and torque and just see what the heck you can do. And
our dynamometer testing isn't over, guys. We're going to put the Spider in the same way.
We're going to take it down next week, yeah.
In fact, Thursday was supposed to be its slot. Now it's going to have to go next week.
We pushed it till next week, yeah.
We're going to run this same test with the high-performance electric vehicle system, which has the Curtis controller that's 550
the 550 amp, yeah.
And then we're going to change the controller. Hold that out here. We got a new one right there. This is the new one that's purported to do 650 amps.
Yeah, it's 650.
And then we're going to take the Spider over and do it over again. Lovely party.
Always wanted to be a hand model.
Yes, yeah. Vanna, Jay. And so that's your Curtis 1238. What's the new dash number? We're using a 7501.
That's a 7601.
7601.
Yeah.
And that is your 650 amp one. I don't think it's really any more money, is it?
No, I don't think so. No, I don't. Yeah, maybe $100 or something.
And Bill Ritchie, by the way, of HPEVS, has agreed to come and speak. He warns us he is not a Nelson Rockefeller.
No,
not a big speaker.
Yeah, not a Zig Ziglar.
All right, but he's very familiar with the product and is going to come to the EVCon for that. So I've got this contest where I happen to know we have some very passionate people.
Right.
And I've got this show, which we're going to move to the airport.
I think that's a great move.
Down there. And I think we can do some fun stuff down there. We're still going to do like the, well, I'll tell you more about that in a minute. So I'm trying to think, who could we get to come speak to this? And we've got a good group. George Hamstra, of course, with NetGain. He was kind of egging me on to do this, so he's kind of...
Yeah, he's got to come.
kind of on the committee.
Yeah, that's right. George is in.
Eric Chris, it was his idea, so he's got to come speak.
They don't know what they're in for.
Right. At our little build school.
Yeah.
With 10 people. And this is going to knock them both sideways.
I know.
Dennis Dorfel is, Dr. Dennis Dorfel is got a very long history testing batteries. If you recall, I was waving his PhD thesis.
Yeah, we talked about him
here.
last week. Yeah.
He's going to come speak. Wayne Alexander. The recurring theme coming through this is people want to do a conversion business.
Yeah. That's a hot one.
Well, if you want to do a conversion business, Wayne Alexander would be the Earl Scheib of electric vehicle conversions.
Yeah, no, Wayne knows how to make money at it.
He's done over 134. Bring me $12,500 in a car, and you too can be a lightning bolt. That's Wayne's theme. He was on the show at one point, and he is a hoot to talk to. You're going to love him. Like I said, I wouldn't do conversions the way he does them, but we kind of differ on that. But he's done more than I have by a lot.
He's got 2 girls and a Cadillac.
And he's got 2 girls and a Cadillac going down the road, baby.
Wayne, you're all right.
Wayne, you're a man. He's going to come talk. And
that's right, man. We love Wayne.
Sebastian Bourgeois from Evnetics is going to come. And Ryan Baum.
Okay.
He does the NetGain drive system.
The drive systems, yeah.
And with EV Source, he's going to come talk. But I was trying to come up with somebody that would be a draw that they would find inspiring. Oh, a couple of guys on my blog are like, why would I come and listen to you for 10 hours? At these shows, it's not really about me. I'm like the host. I introduce people.
Yeah, no, we get
meeting. I got to come up with somebody that they would find inspiring, not long and boring. And the one thing in this contest things, and everybody I've talked to on the topic of why they got started in electric vehicles and what
really kind of pushed them over,
over and over and over. Alex Smith said that everybody I've asked cites a movie, a documentary called Who Killed the Electric Car? Matt Hauber here said the same thing. That's what got him started, was this documentary. The documentary was directed and written by a man named Chris Payne. And let's take a look. I've got the trailer from Who Killed the Electric Car.
All right.
Let's have a look. See why they found this so inspiring.
Okay.
In 1996, electric cars began to appear on roads all over California. They were quiet and fast, produced no exhaust, and ran without gasoline. 10 years later, these futuristic cars were almost entirely gone. What happened? Why should we be haunted by the ghost of the electric car?
The exciting thing about this is the cost of operating the car is the same as if you were driving a typical gasoline car, but the gasoline only costs 60 cents a gallon.
I plug it in at night, and when I need to drive it, I unplug, drive it away.
Believe it or not, that sucker goes. That thing will take you so fast you could get a ticket.
Wow, I didn't know this existed. How come I don't know about this? Have you seen this on TV?
People who control the marketplace today, the oil companies, have a strong incentive to discourage alternatives.
They make too much money with their technological stagnation and the internal combustion engine.
For the last 15 years, they've been telling us the fuel cells are 10 to 15 years old.
There's still roughly 1 trillion barrels worth of oil in the Earth's crust. That's $100 trillion worth of business yet to be done.
General Motors made a commitment to the Hummer because they could see the Hummer would make them money.
The electric vehicle is not for everybody. It can only meet the needs of 90% of the population.
We're up against the automobile industry, the oil industry. It's David versus Goliath.
Who killed the electric car?
Lack of corporate wisdom.
In my opinion, it's big oil.
The murder was committed by the General Motors company.
What's interesting, you're going to be shredding some new cars. Why are you shredding them up?
A little bit of a mystery, really.
Well, that seems like a shame.
I think it will go down as one of the biggest blunders in the history of the automotive industry.
Well, there you go.
Yeah, and it was a very passionate movie. I mean, the people were absolutely passionate.
I have to tell you that I found, having worked in some of the largest corporations in the world, the evil conspiracy thing, that doesn't really work for me.
It's just populated with people. Yeah,
and
not conspiracies.
It's not as well put together as you think.
No one's. They're not having meetings.
Go live in Cubicle City, and you'll see what I'm talking about.
It's mostly incompetence.
It was a good film and an inspiring film, and it does make you a little angry. There were some people in General Motors that made some very poor decisions, and really some kind of vicious ones.
Yeah. They were vicious and stupid.
That were vicious and stupid.
Yeah.
And it pissed a lot of people off.
Yeah.
And
that group of people, it really pissed off.
He's interestingly, Mr. Payne has a sequel called Revenge of the Electric Car, which will be debuting at the Tribeca Film Festival.
Tribeca Film Festival in New York.
In New York on April 22nd.
Yes.
And I've got a trailer for that.
Oh, cool.
This is the most secure location that we could find in the building. You notice we have plenty of security down here.
There's a degree of excitement around electric vehicles we hadn't seen before.
But somebody's got to be the first one out there.
We need a lot of people trying a lot of different things, and then we see what emerges.
It's a race. It's a total race.
You know, until we see every car on the road being electric, we will not stop.
Oh, Elon's going to lose his shirt. Elon's going to get crushed.
God damn it, we got to get these cars out.
Things keep coming along from people outside the car business. They all fall on their butts.
You didn't get the message. Give us the cars that we want.
I got the flood of emails saying, you sold out to the oil companies and you've killed my grandchildren. I hope you rot in hell.
They have based their whole company strategy on it. If it fails, there might not be a Nissan.
You need to predict the future, prepare for it. If it happens, we'll be ready.
These are people who are not going to wait around to have the solution delivered to them.
I want to show the world that it's really possible.
This is the future, and it's attainable.
Timely.
That's a little different. Yeah, yeah.
And
yeah,
it's going to be kind of interesting, contrasting Chevrolet, Nissan, and Elon Musk and Tesla, all in one documentary. I can't wait to see it. I have been in contact with his publicist.
Oh, okay.
And I'm pleased to announce at this time that Mr. Chris Payne will be our keynote speaker on Thursday evening, September 22nd.
That's going to be pretty cool, guys.
We're going to put on a kind of a barbecue, catered barbecue and beer in my backyard overlooking the Mississippi River. There's actually a driveway and a park there and some other stuff, so there's plenty of room for however many come. And we'll eat and have some beer, maybe taste a little the illicit whiskey from the Garage Distillery.
Good God.
And once we're all liquored up, have played with high voltage a bit and had a couple of drives, Mr. Payne will regale us with an inspiring tale heretofore never contemplated in the annals of electric vehicle history, I do hope. And I'm probably going to try to arrange to do a screening of probably Revenge, like on a projector on the side of the house or something, where they can, then the ones that want to stay up late can watch that and drink beer and fight the mosquitoes. Although by September 25th,
it should be a little problem. Yeah. And, yeah, I was thinking maybe we could actually hire the blimp with the, you know, the LCD screen on the side, and just it can hover out there over the Mississippi River.
That would work.
Okay.
Do they have one of those?
I don't know. I shouldn't have even brought
Call
it
around.
up.
God, we tried.
I should have kept my mouth shut.
We tried to get black helicopters in a show for what, 6 years, 7 years?
We did. Couldn't get them.
Maybe we can have a black helicopter.
We can have a black helicopter. Oh yeah.
And
spray paint one down the
yeah,
hangar.
Right. Well, actually, I got some helicopters down the hangar. I think the airport's going to offer some very interesting things. We can do some charging. There is a RV park here in Cape that has like 50 slots for RVs.
Oh,
that
yeah.
have the NEMA 5-50.
And they won't have 50
We'll
people
have
in there.
some here and some down at the airport, but I mean, people are bringing their cars to show.
It's going to be great.
This is going to be...
and we'll see what we can do to promote that car show. As more cars come, you know, we get some interest with the community, the press, so
oh, yeah.
bring those cars along.
We'll get a parade going through town and, you know, have a few hours where the public
Jack may
can
have to
come
run
in.
for mayor.
Yeah. the mayor in this town
the mayor of
has to run
Munchkinland
from me.
The mayor of Munchkinland.
Harry Rediger, he'll.
Yeah, that's right.
No, they'll love this. We got 4 guys coming from New Zealand already.
Yeah.
You know, Cape's Chamber of Commerce and the mayor and that are going to love this.
Yeah.
Then they'll think they've hit the big time. So that's the show. The dynamometer testing, which we're going to pursue. The Cadillac, Lucian came in and is working on our auxiliary mounting plate, and I mean, that's a live program. We've got to get our batteries in, get that plate done, and some other things. A couple of our readers thought they saw a black car in the background of one of our recent shows.
Here?
I assume they mean
this,
the Winston Battery Escalade.
Yeah, the
right?
Winston Battery Escalade.
That was probably what they saw.
Okay.
Bad camera angle.
Yeah, shadows.
Shadows.
Yeah, optical illusions. Yeah.
Before we go, you talked to Kerry Hines today. Tell me about my all-aluminum chassis with rack and pinion steering in individual, IRS?
The independent rear suspension.
Independent rear suspension, and a new model of Porsche replica roller.
Yeah, now Kerry, it's a special edition where we've been getting our Speedsters. They've been, they are bringing all of their manufacturing here to Bremen, Indiana. It's been, the car's been produced in Brazil. For a number of years. And they want to get a little bit more control over the quality's been good, but they want to get a little more control over the process. So they're moving in here. And with that move, they are going to rejig, refixture their chassis. What they're doing is making a common chassis for the Speedster, the Coupe, the Cabriolet, and the Roadster. So all 4 cars will fit on that same chassis. With that, we made a call.
He just meant the Speedster. There were no other cars involved in that. That's secret stuff.
Oh, okay. We can edit that out, but if you want. So anyway, so the Speedster's got a brand new chassis.
Right.
So they're working on that, but aluminum is something that we would like to see. To lighten that chassis up, and I think we've heard that would be what, a few hundred pounds.
We're
maybe.
looking at 400 or 500 pounds, Brian. Now it's a combination of things. One is an aluminum chassis, but 120 pounds of it is this air-cooled Willwood
the
aluminum
brakes,
brake rotors, which are probably a little light for long durability, but we're slowing down with regenerative braking on anyway. We don't even use the rotors, and we could save 125 pounds.
Yeah, and it's not that heavy a car with 4-wheel discs. Yeah.
So I've kind of got a concept of a lighter frame with lighter rotors and lighter wheels. And of course, like your Michelin energy savers.
Energy savers, yeah.
But along the way, Kerry Hines has just got bonkers on this. He's got with Chuck Beck, and they're talking about manual rack and pinion and IRS, which would be a huge improvement, particularly the rack and pinion, I think, would be huge on this car.
Well, and the rear suspension, the swing axle, the swing axle has that, sprung weight. It's got that fulcrum in the center. The IRS has 2 CV joints, like most vehicles now, 1 inboard, and 1 outboard on each shaft. The VW, they're equal length shafts. They ride nice, and it's a better. Porsche went to that in the, I think the independent rear suspension maybe in the 60s. Volkswagen picked it up in 1969, I guess, or 68. Went to that. So it just makes the car ride with rack and pinion steering and independent rear suspension. He actually is going to go to, I think he's going to do a strut front end. I think that's what Kerry said. I think he may go to a, so that gives you 4-wheel independent suspension in that
and
car.
Rack and pinion.
Yeah.
Now, so this is sort of a combo deal. They're doing, and Chuck Beck is involved in this, the rack and pinion, the front strut, and the IRS. Anyway, now they're going to do a version of that for us, which could mean you, if you want, that is aluminum.
Right.
Probably not as strong, but much lighter and
lighter.
strong enough, with aluminum billet rotors and a light wheel version of this upgraded frame that I think would be very good for a Porsche replica electric. We could be back under 2,000 pounds. On duh, we could be down around 1,800.
1,800 on duh, yeah.
Pretty easily. And again, you can add power to these cars all you want. We can fight with Jeff and play with this stuff. The magic is not in what you add on, it's what you take out.
Right. Yeah.
When you can lose weight and frontal area, it's magic. It's almost like free.
Yeah, and automotive manufacturing all across the board is going to that. And I think, a lot of the OEMs are going to overdo it and make really flimsy, plasticky kind of cars, especially on the low end. But taken away, because you can't do an aluminum frame on a, on a $20,000 car that they're doing, they're mass produced. But we can do an aluminum frame on this Porsche replica, and there's, a lot of, I think that we can get that done with them, get that tooled up.
Well, we're going to try it, and if we spend a bunch of money on it and get out on the road and it folds up on us like a tent, we'll do that out ahead of you.
Yeah, that's right. You'll know.
I think
it's going to be good.
See, but by the time you put that body on there, and we put these boxes in with the batteries, the boxes don't just bang around in there. They're
part of the chassis.
They become part of the car.
Yeah.
We're still going to be so overstiff that it's not going to matter.
Yeah, I think we're fine.
The batteries almost become part of the chassis, and so we don't need all that. There's enough steel under that car to be a Ford F-150. The way they've got it right now.
That's a very robust
just a wee bit overbuilt for a Volkswagen.
Yeah, it's robust.
And I thought that would be a good thing, but on reflection, it's mostly a heavy thing. And by the time we put the batteries in with the boxes, we've stiffened everything up anyway.
Right. Yep.
And so I'm kind of excited about going to a lighter chassis. With lighter rotors and lighter wheels.
Lighter wheels, yeah.
And I don't think that's going to catch on with their typical buyer.
No.
But with our viewers, all that stuff translates into better handling, potentially vastly better handling. And I think the car is kind of fun to drive now.
Yep. To get even better.
And then more range and more acceleration. We can do that 0 to 60 better by getting rid of weight than we can by adding power.
Yeah, I mean, that's one of the ways to do it. Increase power, decrease weight, and we'll work it from both ends.
All right. So that's kind of what we're doing this week. And we're going to continue to work on the show. I am going to get through that contest stuff, and we will get this done.
So just bear with us, guys. It's
but I do not accept the concept, people spending that effort to enter, and then, it just all going into the trash, and we randomly pick somebody out.
Yeah, no.
We're going to go through the whole process. I'm going to read every word, and we will come up with 10 guys and let our viewers pick the winners, and then we'll settle the stuff.
Yeah.
So I said I'd do it, we'll do it.